Alright, so we're going to do some graphing of quadratics. My questions are normally laid out this way, where I'll list the things you're supposed to find: the x-intercept, y-intercept, vertex, axis of symmetry. In no particular order, I just have them listed here. The order you search for things will usually depend on how the question is set up. So we have y equals negative 0.5 bracket x minus 4x plus 2. So a couple things you can extract from that right away. It is factored form, so that's going to help us find some x-intercepts. And we have a negative leading coefficient. So things that I can see right away, this is negative, so this is a sad curve. It's also factored form, so I'm going to find my x-intercepts first, and I'm going to follow the same patterns I always follow, even though I could extract the x-intercepts right from that format. So I'm going to set my y to 0, and I'm going to solve this little problem. So if I'm looking to solve this, I have three things multiplied together to get 0, which is awesome, because that means either this bracket is 0 or this bracket is 0. So if I set x minus 4 equal to 0, I get x equals 4, which means I have an x-intercept at 4, 0. And if I set this bracket to 0, and I solve, I get x equals negative 2, which means I have negative 2, 0 is my other x-intercept. So if I go to my graph and I plot those here and here, I know my axis of symmetry has to be exactly in between those two things. So if I make a little title, my axis of symmetry, so if I add those things together and divide by 2, so 4 plus negative 2 is 2, divided by 2 is 1. So x equals 1. Now notice this is not a coordinate, this is a vertical line. So this is actually the equation of a vertical line. So at x equals 1, and I'll scroll back up here, this is my axis of symmetry. Now my vertex has to sit on my axis of symmetry. So I'm going to make a little title, vertex, and I'm going to tell myself or remind myself that x equals 1 for the vertex. I get that from the axis of symmetry. So then I go back and I take my original equation and I substitute in a positive 1. So y equals negative 0.5, 1 minus 4, and 1 plus 2. Okay, and then I'm going to solve that piece. So y equals negative 0.5. This is a negative 3. This is a positive 3. So that's negative 9, positive 4.5. And I'm going to make a little note to myself. That's at 1, positive 4.5. It's always nice to end with a coordinate. Okay, so if we take a look, now we go over 1 and up 4.5 and put a dot. Already that's a nice shape. You can see how that's going to be a sad curve. So this is starting to look like everything's going to fit. So my vertex is at 1, 4.5. My x-intercepts were negative 2, 0, and 4, 0. And the last thing I need to find is my y-intercept. So y-intercepts are found by setting the x value to 0. So I make a little title. Y-intercepts, x is 0, and then I substitute in the x value of 0, just like I put the x value of 1 above. Make sure I write down everything correctly here. And then I solve. So this is going to be negative 0.5 times negative 4 times positive 2. So y is going to be positive, negative times a negative, and then 4 times 2 is 8. Times 0.5 is just 4, so my y-intercept is at 0, 4. So if I pop up here and I put a dot at 0, 4, that again supports what I'm looking for here for a sad curve. And then the last one, and this one is sometimes done, sometimes not done. I like it because it helps make my diagram better. It's the mirror of the y-intercept. And all that means is you're going to be at the exact same height as the y-intercept. You're just going to be on the other side of the axis of symmetry. So what you'll find is that that mirror is normally just twice, ends up being twice the axis of symmetry value. And I'll point that out here. So the mirror is going to have the same height as a y-intercept. So the mirror is right here, and you can see it's 1 unit away on each side from the axis of symmetry. And that's one of the properties of quadratics, okay, to have the symmetry piece. So my mirror of my y-intercept is just 2, 4. And once I have all those pieces, I can connect the dots, and there is my nice sad curve with all of the things required that I had to find. Cool? All right, let's do one more. What if we have this one? Okay, so graph the following. So we'll notice a couple things. I'm not in factored form. I'm in a different form. And in this case, I am in vertex form. So right away, I can draw or get a couple pieces of information from this. This is a sad curve. So that's a sad curve. My vertex is at 3, 8. So if I go to the right 3 and up 8, 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8. I put a dot, and I know I'm going to have some sort of shape like that. Okay, so I've already filled in 2 pieces. Let's go after, well, it doesn't really matter what I go after first. Let's go after y-intercept, just since we're here. So y-intercepts, the x value is 0. So all you do is you substitute in 0 into the original equation for x. So you have 0 minus 3 all squared plus 8. So this is going to be negative 9 plus 8, and y is going to equal negative 1. So my y-intercept is at 0, negative 1. So I'm going to put a dot down here. Okay. My axis of symmetry, because I was given my vertex, I can actually find my axis of symmetry just from that. It's the x value of the vertex, so it's x equals 3. There it is. My mirror of my y-intercept, it's going to have the same height as the y-intercept, so it's a negative 1 for height. And then you'll notice it's just 3 units away on this side, so it's going to be 3 units away on the other side. So it ends up being at 6, negative 1. So I've already found most of the information without doing a whole lot of work. The last part is my x-intercepts. And so we have an approximate idea where they should be. They're going to both be positive. You can see that on my graph. And they're going to be somewhere between 0 and 1, and maybe somewhere between 5 and 6, just from looking at my picture. So the question is now, how do we find our x-intercepts? And this is the solving piece, which is quite challenging for a lot of people. So let's go through it. So we need x-intercepts where we set the y value to 0. Okay, so we're going to have 0 equals negative x minus 3 all squared plus 8. Okay, so you have some options. As soon as this is set to 0, you have all of your solving strategies come into play. So you could expand all of this out, create standard form, and then use quadratic formula. You could expand all of this out, create standard form, and see if it factors nicely. So you could also try and solve this just algebraically by isolating the x value. And that's what I'm going to do here. So I'm going to subtract 8 from both sides. And then I'm going to divide both sides by negative 1 to get this to be a positive. And then I'm going to square root both sides. The square root will undo the squared term. It'll free up my x minus 3. And I'm keeping in mind that the square root of 8 has both a positive and a negative value. And then lastly, I'm going to add 3 to both sides. And I have my values of x. So it's going to look something like this. X plus or minus root 8. Now, if we were just solving and all we needed was the numbers for an answer, we could leave it as 3 plus or minus the square root of 8. However, we actually want to be able to plot this, so we have to calculate it. So I'm just going to go 3 plus root 8 is one answer, and 3 minus root 8 is my other answer. And so we grab our trusty calculator. We go 3 plus the square root of 8. Oops, not pi. 3 plus the square root of 8. And I get 5.8 is one answer, which fits with my graph. 3 minus the square root of 8, and I get 0.17, which is my other answer. So if I write those as coordinates, and then we go back up to our graph to see if they actually fit. So 5.8 is somewhere in here, and 0.17 somewhere in there. And now if we connect the dots, we have our graph. And that's it. So I use the same strategies all the time. I like little titles. I like this part where I give myself notes on what I'm using and what I'm finding. And it's always a good idea to end with writing down coordinates. All right, hope that helps.